Welcome to Move to Inspire. Tonight, we look out beyond the blue horizon of our own world and focus on a force of nature so immense, so powerful, that its very existence dictates the architecture of everything that surrounds us. We are turning our attention to Jupiter, the king of planets, a colossal testament to the staggering scale and elegance of planetary physics. For centuries, astronomers have measured and observed this world, but its true inspiration is found in understanding its complexity. It's a world built not on solid rock, but on relentless motion, unfathomable pressure, and a powerful, magnetic core. It is, quite literally, a solar system unto itself. Join us as we explore the dynamic interior, the turbulent weather, and the immense gravitational forces that make Jupiter not just the largest planet, but the orchestrator of our entire cosmic neighborhood. 2. Section 1, Formation and the Great Race. To understand Jupiter, we must travel back to the first 10 million years of the solar system, a time of chaos and intense gravitational competition. In the solar nebula, beyond the frost line, the distance from the sun where volatile compounds like water, methane, and ammonia could condense into solid ice, a massive planet-forming core began to gather. Unlike the terrestrial planets like Earth and Mars, which were limited to rocky materials, Jupiter's core had access to abundant ice and gas. This massive core quickly achieved a critical threshold known as runaway accretion. Once it reached about 10 to 20 times the mass of Earth, its gravity became so powerful that it began to vacuum up the vast amounts of hydrogen and helium gas that swirled around the young sun. It was the first planet to form, and by doing so, it became the most influential. This early, rapid growth defined Jupiter's structure. It is truly a gas giant, composed primarily of hydrogen and helium, the two lightest and most abundant elements in the universe. Its overwhelming presence permanently changed the distribution of mass, determining where the asteroid belt would lie, how fast the outer planets would orbit, and ultimately, ensuring that Earth would survive to become a thriving, life-bearing world. 3. Section 2, Layers of Pressure. The internal transformation. If you could plunge through Jupiter's atmosphere, you would find that it has no discernible surface. There is no solid ground to stand on. Instead, what you would experience is a continuous, relentless increase in pressure and heat that transforms the state of matter itself. A. The atmosphere and the hydrogen ocean. The visible clouds, made of ammonia, ammonium hydrosulfide, and water ice, represent just the beginning. Below these clouds, the temperature quickly rises, and the atmosphere descends into a supercritical fluid state. As you drop further, the hydrogen and helium are compressed into a form that blurs the line between liquid and gas. Imagine an ocean 1,000 kilometers deep, not of water, but of superhot, pressurized liquid hydrogen. The density here is immense, a direct consequence of Jupiter's tremendous mass. B. The journey to metallic hydrogen. But the true scientific marvel occurs deeper still. Around 10,000 kilometers down, the pressure reaches approximately 3 million times that of Earth's atmosphere. At this point, the hydrogen is compressed so tightly that its atoms can no longer hold onto their electrons. The electrons are squeezed free, creating a sea of highly conductive material. This is liquid metallic hydrogen. It is a bizarre, exotic phase of matter that does not exist naturally anywhere on Earth. In this state, hydrogen behaves less like a gas and more like an electrical conductor, a superhot, liquid metal. This massive, churning, conductive layer is the engine that drives Jupiter's defining feature, its colossal magnetosphere. C. The fuzzy core. At the very center lies the core, estimated to be about the size of Earth. It is thought to be a mix of rock, ice, and metal, a relic of the initial accretion process. However, recent data from the Juno mission suggests that this core is not a neat, solid sphere, but a fuzzy, diffuse region. This implies that the core's materials are slowly dissolving into the metallic hydrogen layer, further blurring the lines between the planet's internal layers. This dissolution indicates that Jupiter is still slowly evolving, defying the notion of a simple, static planetary structure. 4. Section 3, The Weather Engine, Organized Chaos. Jupiter's atmosphere is a masterclass in atmospheric dynamics, transforming the immense energy received from the sun and generated internally into spectacular, organized chaos. A. Belts, zones, and jet streams. The characteristic stripes, the lighter colored zones and the darker belts, are the result of powerful convection currents driven by the planet's internal heat. Zones are regions of rising, cooler air, which crystallizes into white ammonia ice clouds. Belts are regions of sinking, warmer air, allowing the lower, darker clouds of sulfur and phosphorus compounds to be visible. These bands are separated by powerful, high-speed winds known as jet streams that move in opposite directions. This effect, known as differential rotation, is caused by the planet's non-solid structure and its incredibly fast rotation. A Jovian day lasts less than 10 hours. The friction between these opposing wind systems ensures that Jupiter's weather is a state of perpetual, high-speed turbulence. B. The Great Red Spot. The most famous storm in the solar system, the Great Red Spot, is perhaps the ultimate expression of Jupiter's energy. It is an immense, anticyclonic storm, a high-pressure system, that has been observed continuously for over 350 years. It is larger than the entire planet Earth. The storm is contained and fueled by the opposing jet streams that flow along its northern and southern edges, constantly adding energy to keep it churning. Its reddish-brown hue is likely caused by complex chemical reactions, perhaps involving sulfur and phosphorus, that are churned up from deep within the atmosphere and then interact with the sun's ultraviolet radiation. While it has been observed to shrink in recent decades, its centuries-long persistence demonstrates a staggering level of atmospheric stability and power. V. Section 4. The Magnetic Domain and Moons. Jupiter's liquid metallic hydrogen core generates a magnetic field so immense it defines a colossal region of space. A. The magnetosphere. Jupiter's magnetosphere is the largest and most powerful structure in the solar system, aside from the Sun itself. It is so vast that if it were visible in the night sky, it would appear larger than the full moon. This field traps and accelerates charged particles from the Sun and from the nearby moons, creating intense, lethal radiation belts that pose a severe hazard to any spacecraft. The interaction of these particles with Jupiter's poles creates magnificent, permanent aurorae, far more brilliant and complex than those seen on Earth. B. Tidal heating and Io's fire. This intense magnetic field and Jupiter's gravity have profound effects on its four largest satellites, the Galilean moons, Io, Europa, Ganymede, and Callisto. The most striking example is Io, the most volcanically active world in the solar system. This extreme volcanism is not due to Io's internal heat alone, but to tidal heating. As Io orbits Jupiter, the planet's immense gravity constantly stretches and squeezes the moon's interior. The resulting friction generates enormous internal heat, melting rock and causing hundreds of volcanic plumes to erupt constantly across its surface. This constant gravitational tug-of-war is a powerful illustration of the physics of influence, the largest planet actively, physically shaping the destiny and geology of its closest companions. 6. Conclusion. The Grand Orchestrator. We conclude our exploration where we began, with scale and influence. Jupiter's gravity is not just an internal force, it extends throughout the solar system. Its mass determined the fate of the asteroid belt, preventing it from consolidating into another planet. Its presence stabilizes the orbital paths of many inner and outer worlds. And its gravitational stability at the Lagrange points herds vast clusters of asteroids known as the Trojans, keeping them locked in perfect alignment, eternally following the king. Jupiter, the gas giant, is an ongoing lesson in planetary evolution, extreme physics, and the elegance of organized energy. It shows us that the universe finds harmony not in the absence of chaos, but in the mastery of motion. Thank you for exploring the King of Planets with Move to Inspire. Please like, share, and subscribe.